kiddos, today we're going to talk about accuracy and precision. These are two terms that get confused a lot or sort of get mixed up, and really there are occasions where just in sort of normal parlance you could assume that those two things were the same. But in science, those two terms mean something that are related to each other but are not quite the same. And so I want to make sure that everybody knows what they are and specifically sort of knows what sort of bearing they have when we're doing things, when we're doing experiments and doing things in a lab setting. So the first thing we're going to talk about is accuracy. The classic example of this would be of throwing darts at a bullseye. If you're throwing darts at a bullseye, of course it depends on what game you're playing specifically, but in general, if you're throwing darts or if you're firing arrows at a bullseye, you're trying to get right there in the center. And so if I fire 3 arrows or throw 3 darts at this bullseye, and I hit there, and there, then I have really good accuracy. I have really hit within or close to what the true value should be. On the other hand, if I fire my 3 darts or fire my 3 arrows and I hit here, here, and here, then I'm not being very accurate at all. I'm not very close to what the true value would be. Another sort of classic example that I think is a really good one is that if I were shooting free throws, and let's just say that I was shooting free throw shots at a basketball hoop, and let's say that I made 9 out of 10, well, that's pretty good accuracy. I was making most of my shots. If I made 2 out of 10, then that's pretty bad accuracy. I'm not hitting the mark. I'm not making the shots that I ought to make. What this means for us in a laboratory sense is that when you're taking your measurements, are they representative of what the real value should be? Okay? All right, so precision means how close are the measurements to each other. In other words, if you took a series of measurements, were they pretty similar to each other? Or were they really spread out and not close to each other at all? So in terms of our bullseye analogy, if I fired my 3 arrows or threw my 3 darts and I hit one here, and one here, and one here, then that's not very precise. Now you might say, well, it looks like it's not very accurate, and you would be correct. It's not either of those two things. The measurements aren't close to each other. They're also not close to the true value for what they should be. Okay, on the other hand, I might have thrown my 3 arrows or shot my 3 darts, and let's say maybe that they all hit right about here. Okay, really closely bunched together, but not quite where I want them to be in terms of accuracy. This is an example of precise results, meaning that they are close to one another, but they are not accurate because they are not close to what the true value should be. Okay, now these sorts of things tell us a couple of things about laboratory measurements then. So, in terms of how does this work like actually in the lab? Well, accuracy is really important to us in measuring. That makes pretty good sense. You want your measurements to be closely representative of what the actual value is. Now, what works out kind of cool about accuracy is that if your accuracy is off as you're measuring things, if it's off by a really consistent amount, what that usually means is that there's some sort of accuracy issue in your measurements. Like, let's say that you were taking some masses and you knew, your teacher told you, hey, this mass is 3 grams, and you kept measuring it, okay, and you measured it multiple times. Each person in your lab group or all your partners measured it, and every time you got that it was 3.5 grams, okay? And so you're like, well, we're pretty precise. We all got really close to the same measurement, but like we're not accurate. We're not where we should be. Well, what that means is there was probably some sort of systemic error. So for instance, in the case of like the balance thing, maybe there was something sitting on the balance, okay? Maybe the balance was a little crooked. Maybe something was sitting under one end and that was throwing things off. Maybe you happen to each sort of just be weighing it wrong and putting your finger on it. Maybe you forgot to zero out the weight of the weighing tray. Like most of the time we'll have weigh boats that we're putting things in to weigh them. Maybe you forgot to zero it out before you put that on there, and then every time your group was measuring it, you were counting the weight of the weigh boat, and that was elevating it, making it inaccurate, okay? Your measurement was, they were all higher. They were systemically higher. The cool thing there is that if that's the sort of problem, that's the sort of thing that's relatively easily fixable, right? So if you got your data back and you noticed that you were all 0.5 higher than where it should be, and then you went and sort of checked things out and tried to figure it out, and you went back in and saw, oh, hey, we forgot to take the weight of the weigh boat out, and you went and weighed it, and it was 0.5, well, great. Then you found your source of systemic error, and that's something that you could really quickly correct, which is a really good thing. So accuracy obviously is going to be really important to us in terms of measuring things. So precision, what does precision have to do with us doing lab measurements? Well, precision is most important for us in terms of calculations. Now, it doesn't mean that it doesn't matter for measuring. Actually, it matters a lot, and we're going to talk about that. But the precision that we get from our lab instruments then goes into the calculations. And then remember that matters for us in terms of what calculations do we do, and then how precise do we keep our calculations, because precision relates directly into significant figures and essentially tells us how precise do we keep our calculations after we've done things. Okay, precision for us also means that when we're using an instrument, did we go to the proper number of significant figures? So in our example here, let's assume that we were at 1, 2, 3, 4, 5, 6. We're measuring a liquid in a graduated cylinder. You see the liquid has a little curve. Remember that curve at the bottom is called the meniscus. You should always measure at the bottom of the meniscus. We should talk about that in lab safety and stuff, but always down at the bottom of that curve. So I'm at 4 milliliters, so I could record my data as I'm at 4 milliliters. But really, to be precise and to take our measurements properly, remember that we have to estimate a digit past that. I'm not just at 4 milliliters, I'm like exactly at 4 milliliters. So what I would say for my measurement then is that I'm at 4.0 milliliters. Remember that this is our uncertain digit. If you're not really clear on that uncertain digit, we're going to talk more about that in significant figures too. But essentially, when you have a device that you, are estimating things, that you're measuring, like you're eyeballing things, then you always go one digit past whatever the smallest markings or smallest gradations on the device are. That gives you the appropriate precision for that instrument. That's going to be real important to you because you're going to get marked off for that in labs and stuff. If this measured down to the 10th place, then I would have to record my measurement down to the 100th place. I estimate the digit past that. So that's the uncertain digit. Always make sure that you do that. So precision is really important for us in terms of calculations and our manipulations that we're going to do afterwards. Okay? So remember, accuracy is how close you are to the actual value. Okay? And then precision is how close were your measurements to one another. If you went and looked at this and, like, say your lab partners, one of you measured it as 4.0 and then another one came up and said, well, that was 3.0, then obviously you weren't very precise. Your measurements should be together. Not only that, but your lab partner who guessed the 3.0, not only were they not precise in keeping their values all together with you, but they weren't very accurate because the actual value is obviously 4.0. All right, that's accuracy and precision. Thanks, kiddos.